On today's episode, Mazda's one-size-fits-all platform strategy, new solar manufacturing in Ohio, and hydrogen for Australian power generation. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Hydrogen has long been the fuel of choice for fuel cell power generation, reacting to produce simple water vapor. But fuel cells aren't the only way to generate clean energy with nature's lightest element. It can also be burned in conventional combustion processes, and that's something that General Electric has developed with a new dual-fuel gas turbine technology for electricity generation. The company has announced a customer pilot project at the Telluride B power station in New South Wales, Australia. The project aims to accelerate the clean energy transition down under by using hydrogen and hydrogen-blended fuels. The plant will use an advanced version of GE's F-class large turbine technology for 50 Hz applications that can burn hydrogen blended with natural gas in concentrations from 5% by volume up to 100% hydrogen. The project will be largely turnkey, and GE will supply the generator, exhaust stack with a plume dispersion device, step-up transformers, control systems, and gas turbine accessories, all packaged in modules. The unit will operate as a peaker plant, reacting rapidly when needed to stabilize the power grid on demand, and was ordered as part of an Australian federal government initiative to find alternate solutions for 1,000 megawatts of dispatchable power. This capacity is especially needed with the upcoming closure of a 1,680 megawatt coal-fired power station. Federal and state governments have contributed $83 million to the project, and Energy Australia, a large privately owned power utility, will buy green hydrogen up to 5% of the plant's fuel use from 2025 and will offset direct carbon emissions from the project over its operational life. Energy Australia expects to retail entirely carbon-neutral electric power by 2050. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. Photovoltaics are dominated by Asian manufacturers, particularly China, but that market dominance may be changing. Tempe, Arizona-based First Solar has announced that the grid-scale photovoltaic manufacturer will invest $680 million in a new manufacturing facility in Ohio, the company's third, joining facilities in Vietnam and Malaysia. The Lake Township, Ohio facility will be large, 1.8 million square feet, and is expected to employ 500. Most photovoltaic production is made by cutting thin wafers from grown, very pure silicon crystals, but First Solar uses a different technology. The company's thin film technology uses a layer of cadmium telluride about 3% the thickness of a human hair, applied with a vapor deposition process. Cadmium telluride technology, when deployed in grid-scale installations, is the only thin film technology that is cost competitive with traditional crystalline silicon in photovoltaics. Thin film technology also has a low carbon footprint, and the known toxicity of cadmium is addressed with a recycling system that recovers 90% of the compound for reuse in new modules. The company will use Industry 4.0 architecture, AI, and industrial Internet of Things connectivity to produce one module approximately every 2.75 seconds when the facility is running at design speed. The timing of the announcement dovetails nicely with the Biden administration's stated goal of significant federal aid in clean energy deployment, coupled with uncertain supply chain issues post-COVID with Chinese panels and the possibility of politically driven economic sanctions against China. State-of-the-art automation should make the operation cost competitive with First Solar's operations in Asia. With an ultimate annual capacity of 3.3 gigawatts, the new factory is expected to begin production in the first half of 2023. Mazda Motor Corporation is not traditionally the first brand that comes to mind when thinking about green automotive technology, but the company is known for technological independence relative to other major Japanese automakers. As the only major manufacturer to mass-produce Wankel rotary engine vehicles after NSU in Germany, Mazdas have always been different, and the company's new approach to a low-carbon footprint follows that tradition. The new corporate strategy, originally outlined in 2017 and called Sustainable Zoom 2030, and yes, that is what it's called, will accelerate the company's use of connectivity and advanced driver assistance. But the truly significant and different part of the strategy is the use of what Mazda calls sky-active multi-solution scalable architecture. Now, all major manufacturers use common platforms to reduce development costs and enjoy economies of scale while producing multiple models. But the current conventional wisdom is that EVs require unique platforms for maximum efficiency. The Mazda system goes in the other direction, using a common platform for a wide variety of different propulsion systems, including internal combustion engines and, surprisingly, engines mounted both transversely and longitudinally in the chassis. The new architecture will consist of 5 hybrids, 5 plug-in hybrids, and 3 EVs rolling out globally between 2022 and 2025. Between 25 and 30, the company expects to launch several pure electric vehicles with a separate, scalable platform. The goal is to have 100% of products with some level of electrification by 2030, with 25% of the product mix being pure EV. The use of a single platform for conventional hybrids, plug-in hybrids, and EVs is very unusual, and it runs contrary to the current industry thinking that battery and drivetrain placement must dictate platform architecture in all but mild hybrid applications. Now, there is risk to this strategy. If battery prices fall notably and charging infrastructure increases rapidly, the demand for hybrids may drop quickly. On the other hand, if factors such as battery raw material supply, electrical grid capacity issues, and poor charging infrastructure, particularly in cities, remain a factor, plug-in hybrids with a small, high-efficiency internal combustion engine may be the right product at the right time. Can the company that made the Wankel engine work make a truly one-size-fits-all automotive platform? We'll know soon. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.